Okay, great for showing up for that session. We talked a lot about performance over the course of the day, and there is one more session specifically dedicated to workload management and partitioning. So Dominik and Matthias will show us some smart partitioning strategy to improve query performance and reduce memory consumption. And in the second part, they will talk about HANA workload management, how you can use it to stabilize the systems and the overall performance. Dominik and Matthias are both working with SAP technology since decades, I have learned. And Dominik ported over SAP systems from Oracle to SAP HANA, and Matthias is enjoying solving complex issues with SAP HANA for more than 10 years now. With that, over to you.
Yeah, thank you and welcome to our session today, Mastering HANA Performance. We wanted to talk a little bit about workload management and partitioning today in our short session. So we try to somehow give it some kind of symbol. So therefore, we're talking about the workload management as a hammer at the end, and the partitioning as a saw to really cut stuff in that it fits. We somehow also divided the topic a little bit, so I will talk about the workload management part, and my colleague Matthias will then talk about partitioning after this. At the beginning, a short overview of the agenda. So we will talk about the different topics, what is part of the workload management, and also later then about partitioning. We will try to show also some cases that we saw in the past, also a combination of these topics. Yeah. So let's start with the workload management. So what is workload management? The objective behind it is really to avoid resource bottlenecks in the systems. Yeah. We all know resources are really limited or limiting factor in the HANA environment, and therefore we have to take care about the resources. There are different ways how we can influence this consumption of the resources, like HANA parameters. We can use the admission control, workload classes, hints, as we heard also today a lot about hints. And also SAP is working a lot on this workload management topic in general. So they are enabling or developing new features and functionalities, and also provide updates to this topic in nearly all of the different revisions which came out over the last years. So we tried just to point out a few of them here on the slide, which are quite handy, like for example with HANA 2 SPS 7. The possibility to really to map also the app source inside of workload classes was very helpful in a lot of scenarios for us. And you see there's also a lot of other topics which were added over the past years. So we try to somehow show a little bit the dependencies between all those components at the end. So the database parameters on the first level is a really general point to restrict the resource consumption in the system, like I guess most of you will know this statement memory limit, which is an example for this, which is really a general setting on the highest level, and it will influence everything. We have the user parameters, which are sitting in between, where you can overrule this kind of parameters also from the database parameter section for specific database users. Within workload classes, you get a lot more flexibility and can really control it on a different way, like restricting stuff really on the application source, but also for just individual SQL statements. And it's getting then very specific at the end for the statement hints at the end. So you see it also here on the right hand side. It goes from the very generic approach really to the most granular approach at the end, to have it really then set up to a single SQL statement or hash. Yeah. So what are workload classes for? It's just a possibility, really, as I said, to manage different kind of workloads if they're running on the same HANA system. So most of you have an S4 systems running somewhere, or other SAP systems, but it's not just running one application or one business process there. So there are different processes. Sometimes you have also external applications, BW systems, which try to gather some information from your central S4 system. And this kind of different workloads come then together. And if you just have the possibility to control it via the database parameters, you're very restricted. And so therefore, the other possibilities, and especially now the workload classes, can be very helpful at this point to really restrict just resource consumption for specific use cases. It really allows a dynamic resource management, not just to a specific application. It can be a user who executes this. It can be sessions, or on the statement level, really to restrict these parameters. To create it, you have just here a small example, which would restrict the statement memory limit and the thread limit. And this is defined as a workload class. Yeah. But at the end, it's very important that you also need to have a workload mapping on top of it, because the workload class itself is just a definition. What are the limits somehow? But you need to also assign then the mapping to it, that the HANA at the end knows which statements should be affected by this. So that's basically the point. Only with the valid mapping, workload classes are really used. Mapping needs to be really created individually. As you saw, it's really an own SQL command at the end. And you have to take care of that a statement can just belong to one workload class. So it cannot be part of multiple workload classes. There's really a one-to-one relation between those. Otherwise, the HANA wouldn't know, okay, this statement is executed for which workload class should now trigger, the more restrictive one or the other one. So it really tries to find out this. If you come to a situation where you create maybe a more generic workload class, which would cover multiple statements, and it would fit, or another SQL statement would also fit to this, there's just a prioritization which is happening here. So if multiple mappings would be true, in the first instance, the number of the use session variables would decide it. The more precise the mapping is, the more or the priority is higher. If it's the same number, there's really just an order of them, which is coming out of the SAP documentation as well. You see the order here. So on the right-hand side, there's a small example. You see here that the BI user is in the left-hand side, just the BI user as the attribute for the workload class. And on the right-hand side, there is also the client and the application component name used. So therefore, as these are more session variables, this is the one which is selected at the end. So what we can also do with workload classes, we can use hierarchies. That means you have the possibility to have parent workload classes and child workload classes. This makes sense in some situations. So we showed a small example here. There's the parent workload class, parent BI it is called. It has a total memory limit of 1 terabyte. 1 terabyte assigned at this point, and it has several other client workload classes defined below it. So in this case, for 3 other BI applications, each of them has an individual statement memory limit defined. So the first one 400 gigabytes, the second one 300, and the last one 600 gigabytes. So what happens now if you come to a situation like this? So you see, you have the first BI application, which is using 200 gigabytes here now. The BI app 2 has 2 instances here running with 200 and 300 gigabytes, yeah. And the BI application 3, in theory, would be able to use 600 gigabytes. But if you sum it together up, you come to this 1 terabyte limit, and the parent workload class is triggering. And at the end, everything which tries to be allocated on top of this, yeah, has no chance at the end. So it is just restricted. And the important thing is, this is just the case as you see it here in the blue frame, that because in this time, the other applications are reserving this kind of space. If in the same time, the yellow BI application 2 would not be active, it would have the possibility to consume up to the 600 gigabytes. So you're pretty flexible in the way what you allow. Then another topic is the admission control. It is just there to prevent overload situations inside of the HANA system. Yeah. So in the normal case, if the system isn't under heavy load, every session can just come in and yeah, do or execute the statements. Yeah. When the workload when the admission control triggers at the end, the requests can get queued at the end. Yeah, so they have to wait until enough resources are getting free and the load is decreased on the system side, that also these requests can be executed. And on top of that, it can also happen that the access at the end is really rejected, so that the session really gets a feedback, or the user on from the outside gets a feedback that the system is under heavy load and that the request cannot be processed. The thresholds to control the admission control are defined usually on the CPU and memory level at the end. And you can define it as a general value on HANA level, but you can also use it inside of workload classes. So also workload classes have the possibility to be set in relation to the CPU and memory limit, or to the threshold at the end, to make then decisions what if additional requests of this type are allowed or not. At the end, it's just important that a workload class admission control can also overrule a global admission control definition. To see also how this is done is just a screenshot out of the HANA cockpit, where you see here the possibility. There's on the left-hand side the parents, and on the right-hand side the child workload class, with the marked fields about where you can define the CPU thresholds and also the memory thresholds. Yeah, admission control. We tried also to show a little bit how it works at the end. So you have the request coming from outside, going to the system, and in the decision manager, the decision is done. Okay, what should be done with the upcoming session here? And these decisions are then triggered on the thresholds, and the information are coming out of the statistic data of HANA inside. And at this point, then the decision is done if the request is admitted. So SQL execution takes place. Everything is then running on this point, or if it's getting queued to the queue manager, which is then progressing afterwards when enough resources are free, or if really a reject happens on the first level. Yeah, another topic, we heard today already a lot about database hints. So hints are at the end useful for the SQL optimizer at the end to find the best way to their data at the end. Or I try to symbolize it a little bit here, some kind of map. And but there are different type of hints also existing. So at the end, as there are these ABAP hints, which some of you know as developer from development side maybe, and also the hints from HANA side. So the main difference which you have to consider at this point is really that the ABAP side has the benefit that even if the SQL changes, so if the SQL hashes may be different at the end, that the hint is also is still executed as it is a part of the ABAP coding. It is transferred to the HANA database and it's executed with the hint. And nevertheless, if the SQL hash at the end changes or not. While when you're doing it on the HANA side, it can happen, especially with inlists, that you have the situation that the SQL looks different at the end. You get a different SQL hash, and then you're wondering why the database hint isn't used at the end. On the other hand side, the ABAP hint has then the disadvantage that you cannot implement it that fast, because you really have to change something in the ABAP coding. You need to transport a change and so on. Yeah, which HANA hints exist? We did it easy here, so we reference to the HANA documentation, but unfortunately, not all HANA hints are really documented there by SAP. So therefore, we also said it's really just an incomplete list. Yeah, but there are also additional notes provided by SAP where you can get some information about database hints. Yeah, in which scenarios hints are helpful? It can be helpful really to improve the performance, to reduce the resources, or also to avoid bugs at the end. So if you have the HANA database and it's doing something which it usually should not do, it's doing some confusing stuff, everything takes long, your users are getting angry, you have the possibility really just with some kind of hint on the map to saying, hey, do it in this way, or avoid doing it in that way, and that can be already the help to solve the issue, and that the statement is executed in an acceptable way, and that the users are getting happy again. So the hints itself can be set on the hash side, so really for a hash defined, or also on the SQL level. Here's the example which I already mentioned previously. So it can happen that the statement hash changes, like in this example with the inlist. You see here there's one variable which is handed over here, and it generates this SQL hash here. But if it changes, so if you have multiple values which are coming, you see you have then different SQL hashes at the end. So you would need to create a lot of these nodes to help the HANA database really to find the right way through the jungle, which can be really annoying. So SAP also realized this, and with SPS 8, there's really a functionality within lists, which really can solve this issue, as HANA is still smart enough to know, okay, there are different approaches which can be used, and it can then use this also for multiple parameters, independent on how many parameters are forwarded. Yeah, and there are also the predefined statement hints, which also are really delivered by SAP. So they are mainly used to fix well-known performance issues, which SAP already found by other customers. The main thing is, it helps really to avoid performance problems. There's also a mini check available within the 1969-700 node, which can be used to check if these delivered statement hints are really installed inside of your HANA system. The thing is, the node is getting frequently updated. So also you should also try or really check how old is the implementation you have. This is also something which this mini check checks. So it can happen that it shows, hey, you haven't implemented it even if you did it, but it's just coming because this node is also getting updated. New hints are added to this list, and therefore we really also recommend to our customers to check this node maybe 2 times a year and implement a current version of it. Here's just one example for statement hints, what they can do. I hope you can read it also from the yeah, okay. And here you just see an overview out of the of a SQL execution. So that's the data collector, statement data collector, and you see here that the elapsed time is increasing here. I try to mark it here a little bit, so it's getting slower in this case than it was previously. And you see in this column about the engine that the engine just changed. Yeah? So previously it was executed by the column engine. Afterwards it was executed by the hex engine. And in this scenario, you see here when you check really when the database was patched the last time, that it on this date it was patched. Also, this issue came up. Yeah? It was just a performance issue in this case. And you see here that HANA is using the hex engine more and more often. And in this scenario, it was just a not so good decision at the end. And to fix this, really, this statement hint here to a no-use hex plan at this, in this example, fix the issue. So hints are very helpful. What you can also do is, as they are so flexible, you can also even use it to assign workload classes if this is needed in your scenario. That really then the workload class is used for the execution of a SQL. So, in general, best practices. Maintain quality assurance systems in the same way. It's really something which we sometimes see that stuff is just implemented in the productive system to fix it there, or to test something there. But it's always good to have also a quality assurance system where you implement the same topics that you can just see if maybe something is coming from a hint, for example, which is active. Workload classes, we really strongly recommend to have a naming concept in place, because when you have a lot of different workload classes defined, it can be really difficult at the end then to find out which one is meant to be used for which application. They support these hierarchies, which I already showed. This can be really helpful, so it's just a tip from our side to use them. And we also always try to define to separate it into different categories. Yeah, to have a workload class maybe for business critical applications, to prioritize these kind of statements in the first level, and also to have the lower priorities, which you can be more restrictive at the end. Or admission control, yeah, you have to always think about it. It's like some kind of insurance. It's better to have it set up and to not use it and do not need it than the other way around. So the system isn't responsible anymore. You cannot do anything. These are situations which can simply be avoided with the admission control. And the last topic, the hints, as I already mentioned, the delivered statement hint node should be checked and updated frequently to get the most of the delivered statement hints, which are provided by SAP. Yeah, that's it from my side. So I would like to hand over now to Matthias about partitioning.
Das Test. Hört man mich?
Ja.
Thank you, Dominik. So now I will start with the topic partitioning, and I need to be a little bit careful because it's one of my favorite HANA topic besides the NSE feature. So maybe I will go a little bit too deep or talk too much. I like the topic so much. Yeah. So most of you, or most of the time when I'm speaking about partitioning, people say it's only about to avoid the technical limit, to overcome the table size limit of 2 billion rows. Before SPS 07, it was 2 to the power of 31, so 2,147,000,000 and a little bit more digits. But with SPS 7, the limit is set to 2 billion via a parameter. So if you forget to partition a table and you reach the limit, then there will be an error message and no more data could be written in this table. And you can use the parameter, you can expand it, but only as a workaround to come around and maybe save the system until the evening when you have an emergency downtime to repartition the table. But at the end, it is a lot more than to overcome this limit. It is improved query performance, like with partition pruning. It's enhanced delta merge performance. If you're thinking of a very, very big table, for example, 2, 3, 5, 400 gigabytes, the delta merge is taking quite a long time. And also the rule of thumb is for a delta merge, you need the memory multiplied by 2. So for 400 gigabyte table, you need roughly 800 gigabyte of memory. For some systems, this might be a big problem. So for example, if you only have a 256 gigabyte system and you have a 100 gigabyte table, so the delta merge roughly needs 200 gigabyte, which is mostly the whole system. And yeah, for sure, data tiering is also a topic why you need the HANA partitioning, and we don't see it so often, but also in scale-out systems, you need the table partitioning for load balancing. Yeah, but per my opinion, scale-out systems, there are some customers which are using a scale-out installation, but it's very complicated if you want to have a good implementation of a scale-out system. So that's, per my opinion, the reason why you don't see it so often. Yeah, and the same like the workload management, there were some very cool new features and functionality over the last support packages. From a security perspective, the partition admin with SPS 07 was a very good implementation, because therefore you needed too much authorities to execute the partitioning. Now it is much more easier for the compliance team, for the security team to give you the right authorities. So yeah, that's a very good feature. And with SPS 8, you have now a third level partitioning. Beforehand, you only have 2 levels. I do not had an example for a third level partitioning. There might be some examples, but for now, we didn't have any customer which are using the third level. So maybe in the next presentation next year, there will be an example for this new feature. Yeah, and as we started, partitioning helps to ensure the performance, the scalability and stability of the system. And at the end, we will cut your data in smaller pieces, but it's transparent for the ABAP application, or for the application which is running on top of the HANA database. It might be transparent, but for developing for performance, you have to be aware of that the table is partitioned, but we will come to this later on. Yeah, it's performance. Like I said, it's the partition pruning to prune a partition. It's the load balancing, and it's the stability. It's the more efficient way for the data merges. So basically, there are 3 types. The type with the less administrative part is the hash partitioning. Most of the sub-recommendations in the HANA FAQ partitioning note are also hash partitionings. There are some special recommendations, like for the financial tables, the ACDOCA, and also some other. There's an extra note for financial tables. And there are also some special recommendation for car systems, There will be an example in the presentation. Yeah, but basically most of the partitioning in the system, normally in standard partitioning system, will be hash partitioning. So if you choose one column to partition it, you have to think about some points like the distinct values in the column and the data distribution in the column. For example, if you're using the client or the mandant, the client as the partition column, it will not be useful. Normally you have the 0 client, and for example, the client 100, and 0 and 100 will be the same hash value every time. So even if you partition the table with client to 10 partitions, there will be only 2 partitions with data, one partition with 0, 0, 0, and one partition with the 100. So you have to check the data distribution, the data cardinality before selecting in the partition. And to start with partitioning, most of the time, the recommendation in the partitioning note will be good. In some special cases, you need another partitioning, or for example, if you want to partition with a range, mostly used with a native storage extension. So you have the opportunity, for example, the table BSEC with GEA, with German Geschäftsjahr, so that you cut your data in 2022, 2023, and so on, so that you are able to activate the NSE feature to do not load the data into the memory for specific partitions. And the last one is the round robin partitioning, but mostly round robin will be used in the BW system. And in the BW system, partitioning is completely another bread because it's mostly done automatically. Not completely, you have to trigger it, but the whole logic, the whole repartitioning thing will be controlled by a BW system. There's one sentence in the subnote: you are not allowed to change BW tables manually. So you are only allowed to use the tools from SAP. It's not like the table EDID4. You can partition it with hash, with range, whatever you want, whatever you need. But if you're thinking of the table starting with /BI, so the big tables and all the other BW tables, you are not officially, you are not allowed to change those tables manually. You have to use the call reorg or the table placement function, even if you're using the SQL command or the graphical GUI. That's what I talk about. Normally you have the one table, one wood sheet, and then you have the opportunity to cut it in some more sheets, for example, with #4, the EDID4, like the column docnum. And if you need to, you can cut it into even more smaller pieces in the second level. The ACDOCA or the POST-DW tables in the car system are a good example. If you have more than 2 billion records per fiscal year, for example, you can choose the hash partitioning in the first level to cut the data, for example, into 4 pieces, and then in the second level, you put them into the yearly, or you combine the yearly data. If you only have 500 or 400 million records per year, you do not need the hash partitioning on the first level. You can only use the range partitioning, and then the range is on the first level. And since SPS 8, there's a new opportunity to have a third level. But as I said before, for now, we don't have any customer situation where we implemented the third level or where the third level is live. Maybe also one reason for that is that most of our customers at SPS 7 right now, and SPS 7 is in maintenance until April 2028, and SPS 8 until November 2028. So from a maintenance perspective, there are only a difference of 6 months. There are some good and new features in SPS 8, but every update needs people, it costs money, so sometimes they're still using SPS 7. If you're using, or if you're still using SPS 5, you should update. it is only in maintenance until the end of the year. And as many of you saw last week, normally it should be only in maintenance until the 3rd of June. And on the 1st of July, the HANA cockpit says that every revision is out of maintenance, even SPS 7 and SPS 8. But 2 days ago, the new HANA cockpit 2.17.7 was released. And with this version, the error is fixed. So SPS 8 isn't out of maintenance. It was just a bug in the cockpit. Yeah, and this is most likely just for you after the presentation. I think you need to look at the table. It's just to have a summary of all the partition specification. There are some technical differences. The first partition specification, which was introduced, was the homogeneous partitioning specification. Then you have the heterogeneous, and there are some differences what you can do. So homogeneous, for example, is hash partitioning is only for homogeneous. There is no heterogeneous hash partitioning at the first level. And for example, with hash and homogeneous, you can only use a column of the primary key, if there is a primary key. If you have a table like the ACDOCA, which has no primary key, then you don't have to use a column from the primary key. But if there is a primary key, you have to use a column from the primary key. So that's, for example, one difference between the technical implementation homogeneous and heterogeneous. With heterogeneous, you can also use a column which is not part of the primary key on the first level of partitioning. But, for example, if you plan to use NSA in the future, that's the reason why the last column is here. Not every partition specification is supported with NSE on the partition level. For example, if you have a range partitioning, homogeneous, you can't use it with NSE. The good thing about it is if the table is already partitioned by range partitioning homogeneous, the change to heterogeneous, if you execute the command, it will be finished in a few milliseconds. In a few seconds, it's like changing the metadata. So, for example. From our perspective, only for multi-level partitioning variants, most of the time we are using the homogeneous partitioning when the second level is always the same. So if I have #2 on the first level, which means I split the data in 2 levels, in 2 parts on the first level, then there will always be the same partitions in the second level. So always 2020, 2021. So there is no chance to change it. But with heterogeneous partition, you can have another sub-partitions on the second level than compared to the homogeneous. So you're more flexible. We are using it if we have more data derivation, for example, with the PRCD elements, that we use it to have another partitions in the second level. And most of the time is homogeneous partitioning. When we are using hash partitioning, we want to have an even distribution of a data. For example, the EDID4, if we partition it by the docnum, most likely every partition has the same amount of data, plus minus 100,000, 50,000 or so on. But we want to have an even distribution of the data. And with heterogeneous partitioning, for example, range in the first level and range in the second level, we can have much more uneven data or more complex designs. And that's the reason why I said at the beginning, the hash partitioning has less administrative, is less administrative at the end, because I use it #10 to EDID4, and I only have to check is there not too much data in one of the partitions. But if I have a very complex range partitioning, I have to check it. For example, do I have to create new partitions at the end of a year? can I use the dynamic range function so that the HANA database will create the new partitions automatically. So I have to know my data and I have to think about my concept. For me, it is way more complex at the end. Also, there's two different technical approaches to partition a table. When you have decided which design you need, then you need to do the partitioning technically, and there's a standard variant which was offline. I think it was renamed 1 year ago, 1.5 years ago. Standard partitioning, which is a technical implementation to repartition a table, and online partitioning will use a table copy, for example. So there are some difference when the data gets locked and how many locks are there on the tables during the partition process, which means if I use the standard approach, for example, on the EDID4 on a running SAP system, there might be some short locks at the beginning and everything will be fine, but during the system is running, there will always be a new delta record because there will always be IDOCs in the system. So even if you execute a delta merge beforehand, there will be a new delta record during the repartitioning. And if you're using the standard partitioning, it will start to repartition the main area. During the main area, it's only intentional exclusive locked. So it's possible to change the data via your DML commands like update, insert, or delete. But when the repartitioning has finished, the main area, it needs also be, or the delta area needs also be repartitioned. And for that, there will be an exclusive lock. And the exclusive lock on the table EDID4 in a running ERP system is like a system still stand. So if you are not able to execute or to proceed any IDOC in the system, it's like a still stand in the system. So that's the reason why you can use the online partitioning. It has less locks, but as I said before, it will work with the table replication. So it's a completely other different technical approach. Normally, it needs a little bit more time. And with like all new things in the system, you should test it in a sandbox. So you should test the runtimes in the system before doing it in the productive system. And as we speak about the performance, partition pruning is a very efficient way to provide a performance boost in large HANA system. So at the end, if you there's one error in the slide to change it. So I will skip to the next one. So for example, here we have a range partitioning on the column department. So HR, IT, production or prod. And then we will do the range partitioning, and then we have a single partition for all the data with HR, all the data with IT, all the data with sales. So before the repartitioning on the left screenshot, if you do select data where department is IT, maybe there is an index on the column department, but if not, the whole column will be scanned until there will be 2 records with IT. After the repartitioning, there's a single partition with data only department IT. And if I do select data where department is IT, all the other partitions which are not IT will be pruned, so will be not read by the SQL statement. And at the end, it will be much more faster because the HANA database only has to read a very small partition. IT departments normally smaller than all the other ones. And the other way around, and that's, for me, that's the reason why it is so important to share the partition tables in your company, is when you have the partition on the column department, and the column department is not part of the where clause, no partition pruning can be happen. So all the partitions needs to be read. And there's one parameter in the system that normally the parameter is in the off state. You so set it on due to the parameter recommendation that the partitions will be readed with multi-threaded. So if you have a lot of partition, you need also a lot of resources to select all these partitions in parallel, which might be a problem if you think you found the best design to do the repartitioning by range or by hash, and maybe at this point of time, this was the best design for the table, but then there will be a new set program, anything else, and the developer was not aware of the fact that the table was partitioned and is writing an SQL command where those specific column is not part of the where clause, then you might have a problem. And we also have an example in the upcoming folders, upcoming slides. Those are only slides to be in here afterwards. So some tips how you can do the repartitioning, which parameters do you need, which tips you can execute. And yeah, there we have the partition example. It was a very, very large car system of a big German retailer, and there are mostly two tables. I will use the short name tlogf and tlogf_x. So at the end, if you at the cash out system in the supermarket, every position from your receipt will be written in those tables. So we are speaking about more than 4 billion records per week. Many, 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 many records. And we partitioned the table. On the first level, we used hash because we have more than 2 billion records per week. That's the reason why we use a hash 4 at the first level. And in the second level, we use a range for 1 week. So that was the only possibility to have a partitioning which matches the high amount of data which will be written into those two tables every week. So due to the amount of data and the fact that there's one country where they are not allowed to archive data, so if they could archive every country, then the old partitions will be empty after 3 months and you can delete empty old partitions. But in this case, all the old partitions, there were remaining 1,000, 2,000, 3,000 records per week. So you can't delete a partition with 3,000 records, so you will lose data. So they had 140 partitions per table, which at the end is no problem for the SAP system, because as we learned before, we have the partition pruning. In the substandard code, the business day date is part of 99% of all the selects in the system. So normally the system only reads one partition from those 140 partitions because of the business day date. So it's no problem for the running system. And also 140 partitions are not a problem because the limit is 16,000. So I have no customer with 16,000 partitions, but some PV systems has tables with 200, 300, 400 partitions. But normally, if your tables are so big, you should think about data archiving, data reduction, maybe deleting some data, because that's very, very high amount of partitions. And then the problem was we designed those partition concept and we implemented these partition concept, and we activated some of the old partitions for NSE. Everything was fine in the system. And then a developer was not aware of the partition, of the partition design, and the new set program was developed and set live without speaking to the basis guys or to the HANA administrator guys, so the normal situation. And then we had the problem. So it's not exactly the executed statement, but at the end, it was a join against both of the tables. But business day date was not part of the join. It was part of the join condition, but not part of the where condition. And the problem with partition pruning is we had, and the first level, the partition was done on retail store ID and business day date. And partition pruning only works if both of the conditions are in the where clause. So main problem, or the big problem here, a business day date and retail store ID were materialized and used for the join, but were not in the where clause, which means at the end, 280 partitions were joined against or joined each other, which was in this case a huge problem for the database because no partition pruning is performed in this case. And we are speaking about a Power 9 machine with 40 cores and SMT8. So a very powerful, a very big machine, not just a little HANA box with 128 gigabytes. And yeah, every night there was a over 90% CPU situation. So the CPU control was active. And because the system was used in many countries, some of the users couldn't work at night. There were delays in the business processes because this situation, it was more than, I think, 30 or 35 minutes at the end where the system wasn't usable because it was at nearly 100% CPU load. The best solution, or technically the best solution, would be to include the business day date in the where clause. So in this case, as you can see in the explain, the system only used the partition with ID 34. Totally easy. The system joined two partitions against each other, less resources, very fast, perfect, cool. But the problem is the customer, or this report listed all the business day date, or there was a logic and they want to find out which business day dated or which business day dates were included in a specific retail store ID. So they couldn't use the business day date in the where clause because it was one part of the result. So in this case, this set program doesn't meet the partition design. So normally the solution would be, if you need the set program, you need to change the partition design, which is not possible because 99% of the load fits the partition design. So they had to rework the complete logic, the complete program, but it was only possible a few weeks later because of development resources. And okay, we change it, and then I will show you the workaround later on. Therefore, there are some best practices about the partition sizes. Normally, you should have, even if you could have 2 billion records, you should have around 250 to 500 million records in one partition. For example, Martin changed some advices for the ACDOCA table. So for ACDOCA, it could also be 1 billion records. So there might be some exception for specific tables. But normally we will use around 500 million records per table per partition. And it should be around about 25 to 50 gigabytes. So one of the rules should apply on the table. And if you're using NSE, you have to bear in mind that a complete partition have to fit into the NSE buffer cache. So you have to check the biggest partition with the biggest columns in your system. And based on that, you have to size your buffer cache, or maybe you have to repartition the table if it is too big. Then write down all the partition table and share this information with development, or share this information in your company. It's very, very important. And test your design beforehand. So maybe you thought you have had a good design or you made a good decision, but then in the productive system, there's one set program, or in the test system, there's one set program. It's only called by one people, one time a week, but it's very important. So as everything, you should test it. And then the combined use cases, the workaround for the car system partitioning problem was during a transition phase, as I said before, until the development would change the program, it needs to run every night. So there was no other solution. And in this case, we built a workload class, bind it to this specific hash, not to a user, only to this problematic hash with the join of the both tables. And yeah, at the end, the set program needed much more time to finish, but all the other users could work in the specific time frame. And it was way more important for the customer that all the users could work in the time frame, and then they have to wait 1 more hour for the result of the set program. But at the end, no longer, or there was no mission control. So the users were happy, and those people who are waiting for the report had to wait 1 more hour, which was okay for a specific period of time. All users could work normally. So
at the end, the conclusion from is both tools, in our opinion, are very helpful in the daily life of a HANA administrator, and they should not be missing in any of the HANA toolboxes from your side. In general, at the end, just a short slide here about the book Matthias wrote together with Jens. So with a lot of more of deep dive information about these topics, but also other topics, currently only available in German, but an English version will follow soon. So that's it from our side. Thank you very much for your attention.
Thank you so much for that insightful and detailed session. Are there any questions left to be answered?
Yeah. Okay. Have you looked at have you experience with dynamic partitioning? And would that apply to this, or would you see benefits? How often do you repartition? What is the effort, or have you automated that?
For example, we are using it in most of the cases when we have a range partitioning on the BSEC table, because then you can have a dynamic threshold of 1 because it's a 4-digit year. So at the end of the year, every time a new partition will be created for the new year. So yeah, that's one point where we use it, and also for the CDHDR, so the header table for the change document. So yeah, at the end we are using it very often, because before the dynamic interval feature was available, we often saw when we investigate an issue, for example, in February or March, that someone forget to create the new partitions for the new year, and then all the data would be written to the other partition. And yeah, at the end, this is not good. So yeah, we are using it.
Yeah, one question. This seems very much that you need access to everything. How does it work out in a managed service environment where someone else is taking care of the basic operational model, would take RISE or any other managed service model? How complicated is that to get into that optimum way of implementing that? Do you have experience in that?
Most of the time, even in a managed environment, you have access to the DB02 or DBA cockpit. And then you can also use the SQL editor in the DBA cockpit, for example, or there are specific scripts. For example, the data statistics scripts for the individual costs, for the cardinality of the data, for the distinct values. Then we are using time frame report and the SQL cache report. So the data from the MSQL plan cache for the current data, for the past, or for the history data. So you could also pack a bundle of scripts, which you can send to the managed provider, and they execute the scripts. We get the data, for example, and then we build the design for the table. Technically, you could also create a workload class with a SQL command. So if you're using the graphical GUI in the HANA cockpit, it's at the end, the HANA cockpit is only executing the SQL command. But I think in a managed environment, you should only create workload classes if you talk to the managed provider and do not do it by your own.
Okay, thank you very much. That concludes the sessions, at least in this room. I would like to ask you to go down to the Audimax again for a closing note, which starts in about 5 minutes, so 20 past 5. And with that, thanks for attending. Thanks again for the speakers. Bye-bye.